Hello everybody, let's get started with week 2 material where we're going to be moving on with unit 1 part 1 and we will move by the end of the week into part 2. These first videos I really want to address some pretty profound questions that sound remarkably simple. Questions like, what is space? What is matter? So I'm going to do a couple of videos on that before we go ahead and move on through the material and sort of cover things like what is science and how scientists go about and operate things. But for a little bit, just a little bit, let's enjoy some of these mind-blowing concepts that have easy questions yet still remain the most elusive answers in all of modern astrophysics. So I'm going to bring up my slides for the day, and we will start with one of my favorite questions. What is space? And I really like my subtitle here. It's certainly a thing instead of a not thing, a nothing. But let's go ahead and jump in with some definitions. If we're going to talk about space, let's go ahead and get what is outer space out of the way. So outer space, a term that we use quite a bit, it just refers to all that exists, all the space outside of Earth and its atmosphere. So when we were talking about our scale model of the solar system, it would be the space between the planets. The planets would be contained in outer space. And then as we move out past our solar system into the Milky Way galaxy, that exists in outer space. And as we move out to our neighboring galaxies, that exists in outer space. And then all the clusters of galaxies and superclusters of galaxies exist in outer space, which is all well and good. But notice, what's between the planets? What's between the stars? A bunch of space. So outer space is full of this idea of space. What is space, though? In a very strict definitional sense, space is the three-dimensional extent where things can exist. That's where we put objects. It's where events happen. So space is like this stage upon which the universe plays itself out. And with that idea of space, space is already giving us some very useful things that seem rather mundane. It gives us direction. So here I have a model of the moon. And in this space of this room, I can move this left and right, forward and back, up and down. I have 3 different dimensions that I can move this object in. So space is 3-dimensional, and we have the 3-dimensional directions. We can define locations, like the moon is over here, now it is over here. So we can actually put it in a place, and then we can define that location. We can have multiple objects in space, like coffee mug and moon, and we can define a distance between them as well. So what is space? It's this 3-dimensional extent where we put things, and within that space we have directions, locations, and distances. Now, that is a rather unsatisfactory definition of what space is. Did that actually talk about the nature of space? No, it just says that we can put things in space. So I want to go into what space really is. I want to dig into this question. Ultimately, I'm going to fail because we don't have a satisfactory answer of what space is. It is an outstanding and mysterious problem that is out there in astrophysics. People still do work on it. We do want to understand the nature of space in of itself. So before we actually get to our modern idea of what space is, the best that we can do, I want to go over a couple of ideas that are sort of the naive, and before we had modern astrophysics, before we had things like Einstein come along, and just sort of the common ideas of what space might be. So if you really sat to the task and thought about the question, what is space? These following 2 definitions, which are not the correct views of space, might be what you come up with. So it's a useful exercise to go through these. The first of these is, wow, I'm not even in full screen mode. I'm just going to continue on, going to embiggen this. So in this first one, the first naive idea of space, again, these are not quite the right ideas, but Traditionally, one of the first ideas people came up with is space is a backdrop. Here we have this big space and we can plop things in it. So here I just have a couple of stars that we have placed in space. Space itself is the emptiness, the void, the nothingness, the vacuum that exists between the objects and pervades past the objects. It is simply the place where we put stuff. So here, space is the backdrop, and then we put things within this backdrop. And what are the things that we can put in there? I have a couple of stars there. So we can also put planets, place planets in space. We can place protoplanetary disks, forming planetary systems in space, other stars in space, planetary nebulae and other nebulae in space, galaxies of both spiral and elliptical, and all the objects of the universe can be placed in space. Now note that we are just putting things inside of this thing that we call space, this nothingness of space. Space is extending out past where we're putting things. So in this idea of space as a backdrop, you could go out past all the stuff and you would find yourself still in the nothingness of space. So with this idea, we have the possibility that space can stretch infinitely in all directions, all spatial directions. So space could be infinite. Although if it's full of a bunch of nothing, now you have some other questions on your hands. What is another idea that people played around with? Not so much as space as a backdrop in which we put things in, but rather space is simply what exists between the objects that are out there. So space as a frame instead of a backdrop. Now in this demonstration right here, I have 3 different stars. We can place them in this 2D space that I've created, my screen here, and we can define the region between them, and the region between them, that's where space is. So space is only defined by the objects that exist in the universe. It's defined as the stuff between it. So space is now in a relationship to the matter. It is what exists between the matter. We put more stuff out there. So now we added some stars and we redefined the boundaries of space. Space is still here. It's what's between the objects in space. Now, if there is a finite amount of stuff, the number of objects, amount of matter that we have in the universe, then this idea of space as a frame has space as finite. There's a finite number of objects, then you could always draw the lines between them and define the space between. And space here again is nothingness, the vacuum, the void that exists between things. So now space is defined by where the matter is, rather than we put objects into a backdrop of space. Again, what does this really tell us about space? Not a whole lot. It gives us a sort of way to define it and maybe some interesting qualities of space of whether it could be, and emphasis on could, be infinite or if it's finite. It's still not scratching my itch of answering, what is space? Is it a thing or is it not a thing? Is it truly nothing? What is the actual nature of space? And this is where we can move into our more modern ideas, the kind that you probably wouldn't just sit around and come up with. In fact, it has taken a lot of scientific effort and some great minds for us to come up with something that we can say about space. We can't tell you what space is, but we can say that space is definitely a thing. Why can we say that space is a thing and it's not a not thing, a nothing? Well, we can say that space is a thing because we can observe it doing things. It has properties. And nothing can't have properties. A thing can have properties. Space has properties. Therefore, space must be a thing. The nature of that thing is still going to be, we don't know, but we can observe space doing things. It has properties. What are the 3 properties? The 3 main properties that we observe? There are other properties of space, but the easier ones to understand and the quick and easy way for you to start learning about this is space is a thing because we can observe space. It can bend, ripple, and expand and contract. So it doesn't say contract there, but if you can expand, you can also contract. And we've observed space doing all of these things, and we observe it doing all of these things routinely now. If you direct your gaze up to the top right corner of my screen, sorry about that. You direct your gaze up here, what you're seeing here is what we call a gravitational lens. Here we have an elliptical galaxy right here, and there's some other galaxy way far behind it. The elliptical galaxy has a whole bunch of mass, both in the form of normal matter and dark matter. Stay tuned for the What is Matter video. So it has a whole lot of stuff there, which creates gravity, and gravity can affect space. In fact, gravity bends space-time, or rather, gravity is the warping of space-time, if you really want to go deep into it. So the light from this distant galaxy behind it is coming out, and then it gets bent, it curves as it goes around this mass. Even though there is nothing there, it is just space, the space is bent. And we can see that effect with this gravitational lensing event. So space is bending here. And this is not the only example of gravitational lenses. We routinely observe these all the time now, and we've even observed them during solar eclipses, which is one of the triumphs, one of the first things that actually show that Einstein's idea of relativity were really onto something. So yes, we observe space bending. We observe space rippling now. We have the LIGO Observatory and now several other facilities around the world, Virgo and more are coming online, where what they're looking for are ripples in the fabric of space-time itself. There are some pretty extreme events that can happen out there, like two neutron stars or two black holes that spiral around one another until they collide and merge together. They are extremely dense and extremely massive, so they end up bending a lot of the space around them, and as they move around and around and around, it's kind of like running your finger around on the surface of water, you generate these ripples. But these are ripples in the fabric of space-time itself, these stretching and contractions of space-time itself that go out through the universe at the speed of light. And we detect that here on Earth, and we've been detecting them routinely for a few years now. So these gravitational waves are an example of where we see space rippling. So the space is rippling. And then based on observations of supernovae explosions and a whole host of other evidence now, we know that our universe is expanding. It is getting bigger. It's not expanding into anything. It's just there's more space being created between everything all the time. That is the expansion. And interestingly, we are now aware that this expansion is happening at an accelerating rate. So something is making the expansion speed up. That's going to be our concept of dark energy, not the point of this video, so save it for another video. But here we see an example of space expanding. We are creating more of it. There is fitting more space between things. So space is bending, rippling, and expanding. We can observe all of these things. A nothing cannot do this. Therefore, space must be a thing. The next logical question, what kind of thing is space? Because that's still very unsatisfactory to me personally. Like, yay, that's a lot of cool stuff. Yeah, that is definitely really, really cool. And it's been fascinating me for decades that space can bend, ripple, and expand. But it doesn't really tell me what space is. It just tells me that space is a thing. And what that thing is, we just really don't know yet. How might you actually start bending your brain around this understanding that space is a thing before I will finally address what that thing may or may not be? And for here, I'm going to adopt this image right here. It's not an accurate model, but it also points you to a really, really cool resource. We Have No Idea, A Guide to the Unknown Universe. It's written by Jorge Cham and Daniel Whiteson. It's a wonderful book, and I was actually reading that book was a lot of the inspirations between these for these lectures. Well, in the book, they imagine space as sort of this cube of jello, this blob of jello, a space goo. And within that space goo, why are they picturing it as a space goo? As this sort of like wibbly wobbly jello type thing? Well, within this space goo, I can put things inside of it, and we just assume that we can just place them there and there's nothing else really going on. And then I could hit the goo and it would wobble. So I could send ripples going through the goo. It'd be the kind of goo where I could stretch it and it could expand. And of course, I could push on it and the goo would bend as well. So this idea of a space goo, if you can picture that in your brain, then it gets these properties of bend, ripple, and expand. Now, this is not even close to a really good analogy, but I really do hope that's helping you paint that mental picture in your head. We wouldn't call this in any science class space goo, although it would be fun if we did that. This is actually, if you've ever heard people talk about the fabric of space, this is what they're talking about. Except it's not just a fabric like a sheet. It's this three-dimensional fabric because we have three spatial dimensions. So this is the fabric of space. And if you really want to get down to the nitty-gritties of it, so the fabric of space, that gives us the three spatial dimensions, but we really live in this four-dimensional universe of space-time, where we have three spatial dimensions plus one time dimension. And we call that, instead of just a 4D universe, we call it a 3 plus 1 dimensional universe, because as we'll see in the video about what is time, time is different. Time is weird. Time is the difficult of the four dimensions. All right, so let's finally address the question. So what really is space? Oh, that's the best I can give you. We really don't know. So we don't know, but I should be very, very careful. We don't know yet. Sure, we've been asking this question since we've been able to ask questions about space. We still don't have an answer. It's fundamental to all of astrophysics and understanding our universe, and it still remains mysterious. Some of the other kind of cool fundamental questions related to this are, let's go ahead and picture that space goo. So if space, if this fabric of space-time can bend, ripple, expand, and contract, what is it bend, rippling, expanding, contracting within? Is our space just some part of some bigger space, some uber space? So is there space outside of space? This is sort of a question that might not even be a well-posed question of what is outside the universe. Or if our universe is, the space of our universe is in some other uber space, is that uber space a part of our universe? And once we go to that idea, we have this uber space. Is that uber space a backdrop? Is it a frame? Does it have properties of its own? Is it a thing or is it a not thing? Are there parts of the universe in which we live that do not have space, like inside of a black hole, where currently our laws of physics break down and you can't even define three spatial dimensions anymore? So you can't define a volume, and if you can't define volumes and dimensions of space, do you even have space? Is space continuous, or can it be broken down further into like individual tiny units of space, a quantized space, kind of like what we do with quantum mechanics, where we break down things into little individual packets of things? So is there an individual packet of space, or is space continuous? And this has some weird sorts of things. I mean, it really feels like it's continuous. I'm waving my hand back and forth through space, no problem. But if we really look down to it, are there like fundamental building blocks of space, a space that is so small that you can't cut it into smaller pieces of space? And if that's the case, it's kind of like we're dealing like this pixelated view of space. So whenever I move my hand, sure, it'd be incredibly tiny to the point where we can't even observe that with any known technology. But part of my finger would jump over into the next unit of space all at once. So space would be discretized. And why do we even play with such a wild idea? Well, right now, our two most successful ideas of how nature works, quantum mechanics and general relativity, do not get along. Quantum mechanics cannot be used to show general relativity, and general relativity cannot be used to show quantum mechanical effects. This is a problem. Our best leading resolution to this problem is this idea of kind of marrying the ideas together in a so-called quantum gravity, which requires, as step one, quantizing space. And then a question that I didn't even address is we can measure the shape of space. So yes, space has shape as well. It's much more complicated to talk about, so I decided not to put it in this introductory course. But we measure the shape of space, we measure it to be flat, which is not like flat like a table, but it's an analogy used in mathematical. So you have to get into the topologies of space and all sorts of really cool and interesting things that are well beyond the scope of this course. But we can measure and observe and define the shape of space. And we measure it to be flat instead of curved in one way or another, either convex or concave. So why do we measure it to be flat? What consequences does that have? So I hope you've really enjoyed this video about not knowing a lot. Space is still mysterious. It pervades pretty much everywhere. I mean, it's all of outer space, and the Earth exists in outer space, so we're all a part of it. There is empty space between our atoms, or within our atoms. So there's space there. Space is everywhere, and we just don't know what it is yet, but we do know that it's a thing, and we are starting to get some ideas of it. There is a lot of potential for groundbreaking discoveries just on the simple question of what is space. For now, though, I'm gonna give it a old shrug, I don't know, and just be curious and hope I learn more. All right, thanks for tuning into this video. I will see you in the next one where I tackle what is matter.